So just a little bit about me and R Markdown. So to be honest, I never touched R until last year, March. And what happened? So when I was in college, so I used to code in C, and then I did some numerical analysis using MATLAB. And then once I got into a grad program, got into my PhD program, I decided to do theoretical math. So for about 6 years, the time that when I use my computer is when I need to latex stuff. That's the only time that I need to code. And then it's about time for me to graduate, right? So I was like, okay, I need to look for jobs. And I first got into the academic jobs. And you know how tough it is, especially for a pure mathematician. And then eventually I realized, okay, I probably is not suitable for academia. It's definitely my problem, right? So finally, I saw that, okay, data scientist is the sexiest job. And I need to make a living. Then what happened? So I had to go back to review my statistics, and then I realized, oh, everybody's using R. Then I had to learn it. So I started using my R while I'm taking some online courses from Coursera. And then I realized, well, it's not really how I imagine using R, because think about it, I used to code in C. It's a low-level language. There's no something called packages. And then I turned into MATLAB, and there's still not something called packages. And finally, when I use R, I had to figure out what packages I should use by Googling and reading things from Stack Overflow. That's just frustrating. But then how I got into R Markdown, I was taking classes, and then all those classes would require me to do reports and like assignments using R Markdown, to code up your stuff, and then also like explain the graphics, what you see from the data and things like this. And I realized, well, R Markdown has some features that I'm familiar with because I can latex stuff. And moreover, I can still code things, and then I can make it organized and consistent. So I got obsessed with R Markdown. And that's why today I'm not going to talk about my mathematical thesis. I'm going to talk about R Markdown. So my topic is let's get R Markdown. And thanks for my SAS friend, and actually he made up the title. And ironically, I'm not going to talk about SAS, and actually I'm trying to persuade people to get away from SAS. Okay, so I feel like I'm going to get into trouble because they're actually recording this. So I will talk about how to use R Markdown and also version control to streamline the model development. So let's take a look at the outline. So now I got a job in Freddie Mac. I'm in the modeling team, and I'm a modeler. I need to do a lot of this modeling stuff, but moreover, I also need to do a lot of data analytics stuff. So from modeling, like from end-to-end workflow, I will first talk about, in general, how we think about what will happen if we need to model something, right, from end to end. I mean, from pulling the data, processing the data, until eventually you got something into production. And then I will talk a little bit about what's the current development process and its challenges. And then I will talk about how we can improve this situation using R Markdown and version control. And finally, I will show you guys a demo if we have time. And I'll make sure that it will be fast because we have a happy hour waiting for us. Okay, so the general model development workflow. So I'm a mathematician, so I like to just like organize things step by step, right? Your math teacher always tell you that step 1 is this, step 2 is this. So starting from data extraction, and then you do some data analysis, feature engineering. Of course, you need to clean your data and then pre-process it. And then you will decide, okay, what will be the model algorithm I should use? What kind of model that will fit into this situation? And then you will start implementing it. And then after that, you will take a look at, what's the testing results. So that's post-model analysis. You need to look at the model error. And moreover, for us, in Freddie Mac, you need to be very careful with the model. And we need to do some sensitivity analysis. We need to do some scenario analysis. What if the home price suddenly drop? right? You know what I mean by that. And then we also need to look at the impact analysis because that has something to do with our securities. And if that doesn't work, we need to go back. If it works, fine, then we let other team to do model validation and then also like user acceptance testing. And then finally, the big thing, documentation. Every single step, we need to document that and tell people that why this model works and why we should use it. This is a very important thing in the corporate environment. And you can see that like from someone who comes from like academia, this is just mind-blowing and how much time that we actually spend on documentation. And then finally, when everything is fine, we let the model go into production. So it seems it's okay, this workflow very clear, right? And also, my company is a good company, so they provide a lot of tools. So currently, what tools that I can use? So for programming tools, of course, SAS. Yeah. We need SAS because we need to deal with a lot of big data sets, and then SAS provide a nice server. So we have a lot of legacy code written in SAS. You cannot avoid it. So SAS, and then of course you need to connect to database, SQL, and of course we also have like open source software, R and Python, and so on. So fine, but we also need to do some data analysis stuff, right? We need to do reporting, we need to do visualization, we need to tell our users why this model is nice by showing them charts. You don't show them data sets, you don't show them numbers, you show them charts. So to do charts, we thank the Microsoft team. We have Excel, we have Word, and of course I forget that I'm using PowerPoint. And of course we also have like internal GUI applications because we have lots of models that they will touch each other. They will just interact with each other. We use some of the model outputs from other models, and then our output generated by our models will also get used by other models. So we need to take a look at if we change the model a little bit, what will be the impact? Or if other people change their model, what will be their impact to us? So that's something we need to do. Okay, so it seems everything is fine, but what reality is, it's like this. So we have a lot of tools, a lot of platforms, but there's some issue like this. Like here, it's like some of my colleagues might be working in using SAS or SQL and do some data extraction, some model estimation because we need the server for big data. But then some of us may prefer to use open source software, R and Python, and then we also can do some testing of the model there. And then whatever these numbers come out, we need to transfer it to Excel, do visualization. And then we also need to put it out into the internal GUI applications to look at its impact. And finally, every single results go to Word because we need documentation. We need to document every single step. So speaking of this flowchart, to be honest, it's kind of messy. And most important thing is like, how can we collaborate? Because remember that when you're in academia, you're mainly working probably like within a small team. But here, you will get a lot of people involved. And every single step, you need to make sure you get it right. So that will pose us a lot of challenges if we are now working in such a process. So what will be the main challenges that we have here? So the first thing, it's difficult to keep track of any changes that you have for your data and code. So when you're working by yourself, you totally know where you put your data, which version you're using, and why you use that. But what if you're working with other people and how you share with them? You need to go back and forth, and at some point, you probably just lose track of which data you're actually using, or which code, which version of the code that you're actually using. And then your colleague might use the wrong data, might use the wrong code to get the wrong results, and then you need to come back again and see what happened. So the second thing is, if it's hard to keep track of the data, of course, we will have less control of the data quality. And you don't want to fit in the wrong set of data to train your model, right? And then also, it's unable to standardize the estimation algorithms for each product. So think about in Freddie Mac, we deal with fixed rate mortgage 30 years, 15 years, 20 years, and then adjusted rate mortgages, and all the other products that you guys might get in real life. And we want to hold a core model that will apply to every single product so that we don't need to write every single product its own set of model code. But if we do it this way, then it's totally unable to just standardize this code, because colleague A might be doing this, while colleague B might be doing something different, and then they need to talk to each other, and it's just tough to keep track. And of course, it's impossible to automate the entire whole process. Then it takes time. And it's inconvenient for collaboration, so that's what I mentioned before. If you're working with a huge team, or not to be a huge team, 10 people, that how are you going to make sure everybody's on the same track, right? On the same page. And then it's hard to reproduce your results. And then finally, it takes a long time for documentation. So we want to reduce the time to do documentation so that we can do more of modeling and research. But then if we need to do so many copy and paste, then also we need to finally piece everything into one documentation. It would just take a month. So to kind of reflect a little bit what we actually need here for this process. So first, of course, we need a programming platform that can standardize all our code. And then we need an interactive platform so that while we're coding, we can also see the graphs. And we can also input text. It's not just the comments for the code, but it's actually the explanation and all these things, how you actually think about your model and then how the model behaves. While you are testing your model or you're training your model, you can immediately just put down all these texts. And then you don't need to come back again while you're documenting it. And also, we need a centralized platform so that you can reproduce your results. Everybody is doing it at the same place. But then remember that we're sharing because we're working in a team. So finally, we need a shared platform with version control so that everybody is using the same code, same version of data, and then that will be for our collaboration. So what would be the ideal approach here? We say, first, we need an interactive and centralized platform. This platform should be able to connect to a database because we need to do an end-to-end model process. So we first pull data, we'll be able to connect to a database, and then we will be able to implement code in different languages. So people might prefer R, might prefer Python, might prefer SQL, no SAS. And then also we hope that we can integrate with the graphics and also text. So that we can, while we're doing all this model testing stuff, we can just generate our graphics that's needed for the documentation. We can just type in our test so that we can document everything while we're doing the stuff. And then finally, we should be able to hook up with the internal GUI API so that we can just push our output into internal GUI and easy to see that what will be the impact if we change our model. And all of this, we need to document them. But underneath, most important thing is we need a shared platform and under version control so that everybody's on the same page. Okay, so let's talk about the solution. So if you're from academia, I feel like I'm just preaching to a choir. And even right now, I feel like I'm preaching to a choir now because everybody knows that, okay, the solution, of course, you need to have something that's interactive coding platform, and then you need a version control. So from my experience, I started R since March last year, and then I got used to R Markdown, and then finally I had the opportunity to join a Coursera team to develop a course from Duke, and then from that point, I was starting writing my first textbook for the course using Bookdown. So that's a package on top of R Markdown. And at that point, when after I joined Freddie Mac, I was like, well, can I actually use some of my past experience to help? So the first thing I could think of is, okay, I need R Markdown for interactive and centralized platform. So what I did is, at that point, my team was busy with documenting the model change. And then I proposed that, okay, what if I use R Markdown and I can generate a template for everybody so that everybody using the same template. And I created the code, and then once you just fit in the data set, it will automatically generate all the table, all the explanation, and all the graphics that are needed. That's the first step. And then finally, we can just combine the entire whole thing together into a whole document, and then we can send it out. Now, in my company, we have the version control, that's Git, is getting more mature. So we're thinking, okay, we want to automate the entire whole process. And we want to do it from the model development process, post-model analysis, and also finally we can synchronize the documentation process at the same time. But then we need the Git to do the version control. And we need to control the code version while we can still enable the flexibility for every teammate. They're doing their own thing. As long as when they make any changes, when they push anything, we know that, okay, which version we're actually using. So here I want to show you guys a demo. So how I pretend that I'm developing a model using Markdown. So that's a package built on top of R Markdown. Let me see whether I can change it here. So a nice job from RStudio. It's very easy for you to just like get a Markdown project, and then they automatically give you a template of it. So here I have a demo, how I'm going to streamline the model development. I can show you guys. This will be the final documentation or final PDF file that I will generate from this code. And you can also find this code from my GitHub repository. So what I'm doing here is I'm trying to just make a model documentation process. So first, I will have an index file, which is easy. And good thing for Markdown is that once you separate all these R Markdown using the lumbering, and then they will automatically separate the chapter for you. So say, for example, like I want to, sorry, it's just a little bit messy here because I cannot just split to, So in this structure, I have the index file, and then you can see that I have some other R Markdown files laid out over there. So once you're lumbering your R Markdown file, they will automatically just split the chapter for you. So it's very easy to finally combine the entire whole thing as a PDF file. So I try to do like a small model to predict the results of a English Premier League game. So I'm a huge soccer fan, so that's why I picked this topic. So the first thing, then it's kind of tough for me because I want to switch from the other R Markdown file. The first thing you need to do, of course, you need to deal with the data. So my data is actually come from the Kaggle European Soccer database. I process it a little bit so that we don't need to deal with a huge database, and I just pull out the data that I needed. It's very small sets of data. So first, you will need to do some, variable summary data analysis. Say, for example, if I want to see like what will be the number of counts of the shot-ons for each situation. I have draw, loss, and also win, and you see that like the majority is actually in win, and you can kind of tell that this data is not a good data set, because if you actually look at the numbers of the game results, win, this class is like way more than the other results like draw and loss, and you can kind of guess if I do a logistic regression, multi-class logistic regression, and this is an unbalanced data set, and that model will not be good. So I'm not trying to tell you guys how to do a model, so please forget about forgive me by doing a lousy model here. So then let's go to the model part, and we'll usually describe the methodology of the model. We'll load our package. So say, for example, here I have a package.r. It's suppose that that's my model implementation. The model implementation code, and then it's like written in a package. And then I will talk about what explanatory variables that I'm going to use, and then also what method I'm going to use. So here I just use a very simple lasso regularization model, and then I will try to use this model on different products. So the first case, I want to focus on the team, Manchester United. So I will use this model and then just split the data set that's only Manchester United, and then train it, and then I got some results, and then I'll report, what the model tell us, and all this kind of thing. And of course, it's boring to see it here. Eventually, I will show you the entire whole PDF version. And then suppose like my another colleague, he or she is more interested in another team or another product, or he or she is responsible for doing that. And then they can also like do a separate product. So second case is Liverpool, and if you are a soccer fan, you probably understand why I picked these two teams. So suppose like you have another colleague who is responsible for another product, and this colleague can just totally just like set up another R Markdown file, and then these two will not conflict with each other. So you can easily just like separate the workload, is enable more flexibility for collaboration. But then eventually when you commit your changes using Git, the version control, you will know that, okay, your colleague making changes here, and then you're making changes here. The two of you will not conflict with each other. But then finally, you will see the final products. Let me go back to my PDF version. So here is my demo. I have my data, and then this is my chapter 2, because chapter 1 is the introduction, and then I have my variable summary, a nice table, explaining what variable that I have in this data set, and then I will talk about like how I split the train data and then testing data, some of the input variable analysis, and also the output variable analysis. And then finally, when I got to the model part, so this is my next chapter. And I first talk about methodology that will work for all different cases. And then I first talk about Manchester United, the model results. Well, it seems like it says if you want the Manchester United to make a draw, it only matters whether it's a home game or an away game. So you see that the model is just terrible. And if you want to get a loss, it has something to do with whether the team has some crosses, but then minus the opponent team's crosses, number of crosses. If you want to get a win, you should not foul so many. And then what's weird is like you should not also like pass so many. So the number of team crosses, have a negative parameter in front of it. And you should have more possession. So we probably can know that why this season Manchester United is not winning that many, because they are losing their possession. And then finally, if you're in a away game and you're probably like not in a favor of winning, and you see that right next to it, you can just piece these two together using Markdown, and that will be the second case when you have Liverpool, and then it tells you that under this model training, there's no way for you to get a draw, well, which is just doesn't make sense. And then if you want Liverpool to lose, you probably like Liverpool should not just like it will be negatively correlated with the team crosses, and also if they're in a away game, and then they will be more likely to lose a game. And then for Liverpool to win, it's also negatively correlated to team crosses, which I don't understand. And then it would be positively correlated to the possession time of the team. So Liverpool right now is on the 3rd, I believe, in this season. So apparently, they're doing basically the same thing here. So let's get back a little bit of my slides. So there, I did not show one thing is how I coordinate, the collaboration using Git, because I just don't have the Wi-Fi, so I don't want to show that part. But usually what you can imagine is in the Git repository, so suppose you have multiple colleagues working together for one project, then you can put all your model code package and also documentation template into the master branch. And so then you can set up different branches like Manchester United, and then you will have one colleague called Lizzy Huang working on that branch, and then she can just like change whatever she like and feel like, okay, for this particular data set, for this particular case, how I can change my model. And then you will have another colleague working for another branch called Liverpool, and then this Lizzy Huang will just like try to come up with different set of parameters that will work particularly for Liverpool. So now everybody knows how to find me on Facebook and Gmail. And please don't hack my account. Okay, so I've talked too much, and let's do a summary. So we say that in the current model development process, we use multiple programming and reporting tools, but they're not necessarily integrated. So that will take us more time to actually do this redundant work. So the lack of interactive coding platform version controls creates difficulties and also challenges in tracking the code and data changes, how to standardize your code, and how to reproduce your results, and also it's inconvenient for collaboration, and of course it's impossible to automate this entire process. So R Markdown together with Git will provide the ideal solution involving an interactive and centralized platform and with version control, so that it's much easier and you can also synchronize the documentation process while you are actually doing your modeling. Okay, so thank you very much.